Hi students, welcome to today's class. Today I am going to explain a very important topic. So that is a very useful for solving differential equations. They are, or we can call them as a short trick formulae. So let us see that. Let us find the derivative of xy with respect to x. The derivative of the function xy with respect to x. So it is a function x into y, just we apply the product rule. So what is the product rule here? So this is equal to x into the derivative of y is dy by dx plus the derivative of x is equal to 1 and then y into the derivative of x is equal to 1. Understand this? Now what I am going to see, already we know that, so dy by dx, we can separate dy and dx now at this stage. Now multiply with the dx, see what happens. The derivative of the differential of, now we can call it as a differential of x and y is, here also dx will get cancelled plus y into dx. So this is a very important format. That means whenever you come across x into dy plus y into dx, in that place you can substitute differential of x into y. So if you know this type of formation, that is x dy plus y dx is equal to d times xy. So while solving the problems, this type of formations will be very useful. So let us see one more type this. So what is the derivative of x by y? This is a quotient rule we have. So what is the quotient rule we have? That is y into dy by, so u by v, v into du by dx minus x into dy by dx whole divided by y square. Okay, now take the dx to right hand side, what happens? The derivative of x by y is equal to, so if you multiply this here, y into dx minus x into dy whole divided by y square. So in our course, whenever if you get y dx minus x dy by y square, you can write down the derivative of x by y. Let us see one more example. That is a derivative of, this is x by y, no, this is a y by x you take. The derivative of y by x you take. Apply the quotient rule, u by v formula, that is a x into dy by dx minus y into x derivative is 1 by x square. Understand this? So this is given by d of y by x is equal to x into dy minus y into dx by x square. So this is a derivative of y by x. So different types of forms we have here. Different types of formations we have here. Okay, so I am going to give a list of formulae which are useful for your examinations. So let us see that information. Okay, welcome back. So here I have given very important differential formats. So whenever if you get dx plus dy, then you can write down d of x plus y. Dx minus dy, if you come across such things, therefore derivative of x minus y you can write down. So that if you take the integrating on both sides, integration differential will get cancelled, you will get either x plus y or x minus y. So this is very easy to understand. So this already just now I explained, the derivative of x into y is so x into dy plus y into dx. So here also derivative of x square plus y square. So if you come across if you come across this format, that is 2 times x dx plus y dy, therefore you can write down d of x square plus y square. Why? Because you see the reverse order. So if you generally students, if they given this format, they can write this left hand side format. You can, if the right hand side format is given, you can write down easily left hand side format. But here now you have to think in a reverse order. Reverse order you have to think. If it is given d of x by y, that is by parts formula, you can write down y into dx minus x into dy by y square. But you have to remember now in a reverse order. So given this format, you have to write down the derivative of xy. So if it is anything, it is given, so you can write down d by dx, this is equal to, your answer is x by y. What is the integral of y dx minus x dy by y square? Simply x by y. Understand this? Understand this format? So this also x dx, so x dy minus y dx by x square is equal to the derivative of y by x. See, remember how to remember. If it is a denominator is x square, here also denominator will come x, u by v formula. Denominator v square you have to get. If it is denominator y square, you have to get y. Denominator y here. If it is y square, y, therefore x by y. If it is x square, here denominator x, therefore y by x. Okay. So x dy minus y dx by x square. Okay now. Right. So very, very important, one more format is this is, if it is y dx plus x dy by xy is there, then the derivative of log of xy. Then how to remember, sir? Very easy. Find out this derivative. Derivative of log of xy. What is that? Log x derivative 1 by xy. Again the derivative of xy. The derivative of x is equal to y dx plus x dy. Same thing. Both are same. That means you have to remember all the formulas in a reverse order. Here also the derivative of log of xy. So what is the derivative of this is 1 by x by y into the differential of x by y. So the differential of x by y is this, y dx minus x dy upon y square. Understand this? Y square. So here 1y will get cancelled. So here y by x, here x will get cancelled, 1y goes there. Understand this? So you will get this dx by x minus dy by y is there. Then you can remember this derivative of log of x by y. Okay now? So the thing is here, all the formulas, if you remember in a reverse order, so improve your memory power. If in a reverse order, so while doing the problems, this type of formats will be very, very useful. Okay now? So let us see some more results are there. So I will explain them. Okay. Welcome back. So let us see some more results. If it is if you get this type of format, so that is equal to 2 times x dx plus y dy by x square plus y square. You can write it as the derivative of log of x square plus y square. Sir, why sir? So what are the proofs, sir? So find the derivative of this function. So what is the derivative of this function? 1 by x square plus y square. The derivative of x square is 2x into x dx y square, 2y into differential is 2y. Take 2 common outside, you will get this only. So 2 times x dx plus y dy by x square plus y square is equal to derivative of log of x square plus y square. Okay now. So reverse order always remember. So this is also very, very, very important format. So this is also a very, very important format. So if you come across this like this, integral of d of y by x by 1 plus y square by x square, this is simply the derivative of tan inverse of y by x. So the answer for this is tan inverse of y by x. Simply you can write down y. So what is the derivative of tan inverse of y by x? This is 1 by 1 plus x square into y by x derivative. So derivative of y by x. If you write down the derivative of y by x, you will get this only. Understand this? Very nice problem. So this is also here x dx plus y dy by root of x square plus y square. So here the derivative of root of x square plus y square is root x is 1 by 2 root of x square plus y square. 2x plus 2y. Okay now? Take 2 common outside. So 2x into dx. 2y into dy. Differentials you have to take. If you take 2 common outside and you cancel it, then you will get the answer. So here also, so minus 1 by xy. So what is the derivative of minus 1 by xy is 1 by x derivative. 1 by minus 1 by x square. Already minus is there. Therefore, 1 by x square y square. What is the differential of xy? So x into dy plus y into dx. That means given in this format, if you come across anywhere while solving the problems, if you come across this format, that is x dy plus y dx by x square plus y square, then you are able to write, you should able to write down that as a derivative of minus x by y. so that if you take the integration on both sides, here integration differential will be get cancelled. So, if you take derivative to here, if you take here, so this integration differential will cancel 1 by minus 1 by x by v will be your final answer. Okay. So, using this all this whatever we learn now, I will give some formulas. So, without taking much time, immediately you have to tell the answers. Okay, na? So, let us see that problems. Welcome back. So, here I have given various forms of differential coefficients. Okay. Then how to express this in a single differential? Okay, now first you see here, if you observe this, this is just like whenever minus is there, something denominator is there, immediately you have to express this as a derivative of something numerator by denominator type. Understanding something numerator by denominator type. See here, denominator what is there? Y to the power of 4 is there. U by V formula, U by V. So, I am writing here what is U by V formula? V into du by dx minus u into dv by dx by v square. Now, what I am telling is, given this form, you should be able to write down that reverse order. Derivative of u by v, you have to be able to write down. That is why whenever you are learning the formula, so you have to, generally students what they will do now, from left hand side to right hand side they will start learning. But always you have to write down, if the given right hand side, how to write down left hand side also you have to remember. Okay, now. So, coming to here, then if given this right hand side part, how to write down left hand side part, that is our main topic of discussion today, right. So, here if you observe here, if it is a v square, you are writing v here. If it is v to the power of 4, you have to write down v square here. Okay, that means v square means y square. So, here if it is y square is there, after differential you will get here y to the power of 4. What will be the numerator? That is u by v, v into 3x square integral you have to write down. That means x cube. If you write down x cube, therefore derivative of x cube by y square is equal to how much? This only you will get. That is equal to y square into the derivative of x cube is 3x square. Again x differential is dx minus here x cube you will get v, x cube into the derivative of y square is equal to 2y into differential of y is dy by v to the power of 4. That means you have should be thinking a critically, okay, na? Analytically, critically you have to think, okay, creatively you have to think. Now, coming to here, whenever plus is there, so you will have a something derivative into some u into v formula, u into v formula. What you will get? See here, y cube derivative 3y square, x square derivative 2x. That means this is nothing but x square into y cube. The derivative of x square, the differential of x square into y cube is nothing but this. See here, x square into y cube differential 3y square, again y dy by dx. Again this is y cube x square 2x, right. So, very very important point, this is the derivative of this is. Whenever plus is there here, so if you have two functions and the plus is there, so always it is u into v formula. If it is in the numerator and by denominator is there, again minus is there, this is u by v formula. This is a quotient rule and here product rule. Then how to do this? See here, you can write it as sin x derivative is cos x. That's why you can write it as a sin x into log y to the base e. See here, first sin x, you will write down sin x, log y to the base e, derivative is 1 by y, again y differential dy plus log y to the base e, as it is you will write down sin x derivative cos x, again x differential dx. Okay, now. So, these are the techniques that you have to be remember. That means, so far what you have learned, given these formats, if you given this, you are able to write down this format. If you are able to write down this format. Now, what I am telling is, you have to remember in a reverse order. Given this format, you should write this. Given this format, you have to write down this. Given this format, you have to write this. Understand? Reverse order, you have to think. Understand? So, if you know the techniques, the solving the problems will be very easy. Okay na? So I hope that you understand this concept now, and let us move to one more method of solving the differential equation. So far I have explained a variable and separable method. Now I am going to explain one more method. Okay, so let us see that. Welcome back to this concept, that is homogeneous differential equations. Okay then before learning this homogeneous differential equations, if homogeneous differential equations are given, then how to solve that differential equations. So before that, first learn what is homogeneous function. Let us consider a homogeneous, one function, not I am homogeneous, in the variables some y square minus 3xy. So here both the variables are there, x and y both are variables. So f of x comma y is a function, I am telling function. Then how you call it as a homogeneous function means, in the variables x substitute some lambda x and lambda y. So here lambda is a non-zero real number, any real number, non-zero real number, whatever may be that you substitute, but it should not be 0. So if you substitute 0, what happened? Everything will become 0. Okay na? Right. Of course, if any constant is not there, something which is not equal to 0. So wherever x is there, substitute lambda x, here y is there, lambda y. Substitute, see what happens, lambda y whole square plus 3 into lambda x into lambda y. I substituted. So this is lambda square y square 3 lambda square xy. You can take lambda square common. Again you are getting, this is lambda square into f of capital F of x comma y. That means f of lambda x plus lambda y, you are getting lambda square into f of xy. Again you are getting your original format f of xy. Before that you are getting some lambda square. Then we call it as a homogeneous function of degree, what is that here? 2. What is the degree? 2. Understand this, it is a homogeneous function of degree 2. Let us see that one more example. For example, you are given a function of the form f of x comma y is equal to x square by some 3xy. Yes, otherwise x square by, you can cancel, otherwise x square plus y square by 3xy. X square plus y square by 3xy. Okay, let us check that is a homogeneous function or not. So to check that homogeneous or not, in place of x substitute lambda x, that is substitute lambda x, here lambda y. So this is lambda square x square, this is lambda square y square plus 3 times lambda square xy. Understand, in place of x lambda x, in place of y lambda into lambda, lambda square. So I can take lambda square common in the numerator, in the lambda square also common in the denominator. Lambda square gets cancelled. You got your original f of capital X. But what about here? Can I write down lambda power 0? Can I take lambda power 0? Right. So this is also a homogeneous differential equation of degree 0. Degree 0. This is a homogeneous differential equation. Whatever may be that lambda power is there, no, that is called degree of that differential homogeneous differential equation. First of all, so from this I can say the definition is a function. I will write down the definition. Okay. See the definition of homogeneous function. A function f of x comma y is said to be a homogeneous function if f of lambda x plus lambda y is equal to lambda to the power of n into again capital F of x comma y. Understand, this n, whatever may be the n, is called the, this n is called the degree of that differential equation. It may be 0 or 1 or 2 or 3 or whatever may be that. Okay now, right. Let us, is there possibility sometimes there is a chance of getting a negative differential also. For example, if you take f of x comma y is equal to x square plus y square by something 2x, if it is a 2x is there. Now it is check whether it is a homogeneous homogeneous function or not. Check f of kx comma ky, that is k square x square plus y square. So here you will get so this is equal to 2 into kx. So 1k you will get cancelled. So that is equal to k by k into x square plus y square. That is lambda into x square plus y square by 2x. 1k you will get cancelled. Therefore, lambda power 1 is there. So this is a lambda power 1. Therefore, 1 is the degree of the differential equation, homogeneous function. Let us take one more example. For example, f of x is equal to x comma y is equal to some sin x plus 2x. So that is f of x is equal to 2y, call it as 2y. So this is a lambda x into comma lambda y, sin of lambda x plus 2 into lambda y. So you cannot take common outside. You cannot take lambda common outside. Therefore, it cannot be a homogeneous function. The first thing is the lambda should come outside. The lambda should come outside and you have to regain your original function. Then only we call it as a homogeneous function. Whatever may be the power of the lambda power n, that will be your, that may be positive, may be negative. Definitely you will get an integer. You will get either 0, 1, 2, 3 or minus 1, minus 2, minus 3 also you will get. Okay na? Right. I hope that you understand this, what is meant by homogeneous function. Let us see what is homogeneous differential equation. Okay na? Welcome back here. Now I am going to explain a homogeneous, what is meant by a homogeneous differential equation. A differential equation of the form dy by dx is equal to f of x comma y, a function dy by dx, is said to be a homogeneous differential equation. It is said to be a homogeneous differential. So this is a very, very important point. So f of x comma y is a homogeneous function of degree 0, 0, 0. That is a very, very important. Whatever may be that dy by dx, the right hand side function should be a homogeneous function and the degree of that homogeneous function should be equal to 0. Then only we call it as a homogeneous differential equation. Generally, if it is a homogeneous function, the degree may be 0, maybe 1, maybe 2, maybe 3, whatever may be that. But here, to say that a function is a homogeneous differential equation, this should be of the form dy by dx is equal to f of x comma y, otherwise dy by dx or dx by dy, nothing wrong in it. So f of x comma y, and the f of x comma y should be first condition homogeneous function and its degree should be 0. See here I have written some examples of homogeneous differential equation. So you concentrate on the right hand side part function. So what is the degree of this? First of all, is it a homogeneous function? Yes, it is a homogeneous function. How can you say? Wherever x is there, substitute lambda x. This is lambda square x square plus lambda square y square. So this is lambda square plus lambda x into lambda y. So here lambda square you can take common in the denominator, also lambda square you can take common. Lambda square will get cancelled. You will get lambda power 0, that is x square plus y square by, so here x square in plus xy. So that is lambda power 0. Lambda should be cancelled. So here also, therefore this is a homogeneous function of degree 0. That means lambda should be in the numerator, lambda should come outside. Denominator also lambda should come outside. Both should get cancelled. See the second examples also. Here also you put here lambda y plus here also lambda square x square plus lambda square y square. Lambda square you can take common outside. So, root of lambda square, generally we take positive value only. So, this is a lambda of root of x square plus y square by lambda x here, x lambda. So, you take lambda common outside, lambda get cancelled, again you will get original form. So, here also same thing. So, this is minus e to the power of x by y, lambda x by lambda y, lambda will get cancelled, lambda x by lambda y, or kx by ky, kk will get cancelled, x by y, lambda x by lambda y. So, this is also a homogeneous function of degree 0. That is why this total format is called homogeneous differential equations. Okay, now our aim is to solve this type of homogeneous differential equations. How to solve, what are the methods, how many types are there, all these things we will discuss in the next class. Okay, I hope that you enjoyed today's class with the solutions of this homogeneous differential equations. Next class I will come to you. Until then, all the best.